I will be talking today about how language engineering could be made more accessible. Implementing a software language requires specifying its syntax as well as static and dynamic semantics. While conceptually none of these are particularly challenging tasks, developers often struggle to bring their languages to life. One of the obstacles is the absence of tool support for the language. Indeed, users of a language expect nowadays an integrated development environment to be shipped together with the language. I would like to show you now a subway map with three lines, red, green, and orange. The stations on this map will represent tools that could be used to define software languages. Let us focus first on the red line. It has two stations, no tool support and language workbenches. Quite often we do travel along this line. We, as language engineers, either implement a language manually with parsers and all the stack around, or use language workbenches. Those are tools that allow specifying syntax, typing rules, and code generators for a language, and they output a tailored integrated development environment. Despite their advantages, many of the language workbenches have a very steep learning curve. Consequently, their adoption rate still leaves much to be desired. So, while language workbenches are yet to become ubiquitous in industry, a noticeable amount of modeling is still done using word processors and spreadsheet calculators. I have here an example of how a major insurance company used to define certain insurance rule using Microsoft Word. A specification similar to shown here could have been prepared by an insurance expert and then handed in to a software developer, who then manually transformed it into code in a general-purpose language. Recently, this workflow has been changed to use Language Workbench JetBrains MPS. Based on this, I would like to explain you now the idea of how Microsoft Word could be used to define languages. The idea is that in order to define a language, one will have to provide examples of code written in the language being defined. The examples would be then annotated to specify different concerns of language definition, such as abstract syntax, typing rules, validation rules, and so on. Three possible implementation strategies of this approach are considered: using a rich text processor, Jupyter notebooks, or implementing a dedicated example-driven language workbench. These are represented as stations along the green line in my subway map. I can travel through the tools, starting with the most widely used and finishing with very niche ones. Our next station is Microsoft Word. I have here a famous example of the Ms. controller. To define the language, I have written an example of code that represents a state machine. The first state is represented in a textual way, and in the second state I am using a tabular notation, benefiting from the fact that Microsoft Word is one of the most powerful structured editors. My sample code is full of documentation comments. I could have even inserted a couple of figures here and there too. The idea now is to communicate various aspects of the language definition by using numerous formatting styles of Microsoft Word and the possibility to add review comments to text fragments. For example, here I have added a review comment for this events section block. Inside this section I have several event declarations which I define using review comments again. Let us have a look at this state definition here. This state mentions two actions: unlock door and lock panel, and both have to be declared before they are referred to. My Microsoft Word review comment says that lock panel must be an existing command definition. Here the words must be an existing are part of the meta language. In the definition of the second state over here, the part of the table that is assigned some semantics is in dark magenta, including the lines of the table itself. The third column is just my documentation. After I have defined and annotated an example document, I would get a validator for other similar documents. This validator would provide domain-specific error messages to the users. Another possibility is that an API for processing the model will be generated from my sample specification. I will then be able to use the document model of a Word document not in terms of lines and paragraphs, but in terms of my domain. Finally, it could be possible to define a code generator using the very same review comments in Microsoft Word. However, this seems to be quite cumbersome. I have another brief example over here. This defines robot control language. In the first line, I give an example of a turning command, as is annotated here. I specify that this is a turning direction and the possible options are left and right. I can then specify that the distance should be a number and that the only distance unit allowed is meters. Over here, I give an example of the Java code that I want to be generated from the statement in my robot language. Now, I would like to briefly mention the other two ways to implement the idea of annotating the code. I will not focus on the notebooks station, and our next station is example-driven language workbench. Here I define a language of objects that I call entities. In the tool, I will first type in as simple text these 3 lines of code. To communicate that this piece of text is an entity, I would select the text and create a new language construct using the context menu of the tool. In somewhat similar way, I would annotate other parts of the specification. Here I have an example of how code generation would be defined in an example-driven way in the tool. I first define the language construct and then give the sample output where I select the varying parts and bind them to the values of the features in my language construct. We have been traveling from station Microsoft Word, which is a very widely used tool, through the stations representing more and more niche tools. Let me now talk about the orange line in my subway map. This is a magical line in the sense that on that line you can get from any station to any station directly. What this orange line represents is that ideally it should be possible to convert, to some extent, the meta languages of the tools into each other, of course, limited by the functionality of the least powerful tool. What might make sense is to convert a language definition in Microsoft Word into a language definition in JetBrains MPS, for example. Thus, Microsoft Word would serve as front ends accessible to domain experts not familiar with the dedicated modeling tools.